Okay, in this video I'm going to talk about how to find a parametric representation of a line. Okay, so begin with, let's consider the line starting from 210 and 033. So you can change it, it doesn't necessarily start with these numbers. Example, start from this point 210, 201. You ending at 0.033, and the line, straight line, just connects these 2 points. Okay. The problem is I want to find a parametric representation of this line. So a typical way to represent a line is to use a vector with a parameter, for example, t over here. So here t is a parameter. Since this is a 3D space, so the parameter, the vector will be also 3D, which means I have r1t, r2t, r3t. Each one is a scalar. So each one is a scalar, and also is a function of t. So it will change over time, over as t changes. Okay, so idea for this one is, assuming that I'm t starting from 0 and to some final time tf. Now when t starts with 0, it will give me, when t goes to 0, we will find a vector. So the vector will be just the starting point of the line. So which means if my t0, I want this vector to be exactly the starting point, represent starting point, which is 210. Okay, so as t grows from 0 to tf, we'll get a number of vectors, and my hope is that every point on this line can be represented by a vector when t is within the range. So essentially, as tf when t is tf, my vector is just 033, which is the ending point. Okay, so this is rtf. Okay, this is a vector. So this first one is r0. Okay, this is what I want to do. Okay, this is also what a parametric representation of a line means. So essentially, I want to find r sub t vector such that this vector, the vector always starting at 0, 0, 0. The ending point of the vector for t starting from 0 to the final tf will cover all points. Will basically cover all points on the line. Okay, so that's the meaning of parametric representation of a line. So one simple, of course, you can have multiple ways to do that. So one simple way is, well, if I would consider this RT have this form, is some value, since I want t to be, when t0, I want this value to be just my initial point is 210. So a simple way think about this is, I can write this one as what a value I have as a starting point. This is my starting point over here, and then I put something time t. The reason I do this way, because if t0, yeah, naturally I do have r0 is 210. It doesn't matter whatever value I put over here, which is great, which satisfies what I want to achieve. Well, then I come to the second question. So what I want the r's of tf to be equal to 0, 3, and 3. Okay, so of course I can select this tf freely. Okay, let's see, I just say once we let tf to be 1, see if that's feasible. So if we do this one, okay, we want to have r tf, which is 1 over here. So given this form, okay, I don't know what this is. Let's say I say I don't know what number I should put over here. Let's say a and b and c over here. See, if I put t is 1 over there, I get r1t. According to this one, I have 201 plus a and b and c time tf is 1, right? Is 1 over is equal to t. This is tft, which is 1, which is I want it to be 033. Okay, which means I have here is so this time 1, it will be the same. So I have 201 plus abc, which is 033. So which means if I select this ABC according to 033 minus 210, now which means I have, this is a -2, 3, and a 2. If I put the 3 values here, here is -2, and this is 3 and 2. Now at least I can guarantee my RTF will be indeed 033. Okay, 1 TF is equal to 1, of course, right? So also because this representation is straight line, because as time goes on, it talks about straight line. What it means is this guy, if you take about this one, this is a vector, right? This is a vector. This is a vector. So this one, what this means, this is a beginning vector I mentioned over here. This is a beginning vector over here. This vector is 2, 0, 1, and this is also a vector. This vector actually is parallel with this vector. It's parallel with this vector, with this straight line. It's like this. This vector, -2, 3, and 2, is this vector. So this is -2, 3, and 2. Okay, actually with the same length of this guy. So it has the same length if you draw it over this way, in parallel. Okay, because a vector, as we mentioned before, vector you can move freely. So I can move this one, the blue line, to here. It will be same as the red one. It's just the parallel. The vector will be the same. So if you let t to be from 0 to 1, you basically scale it from 0 to 1. When you scale to 0, you become this point. As you scale it up to 1, you cover the entire line. That's why this is a parametric representation of line. So basically speaking, if I give you, for a general case, if I give you a starting point, which is, let's say, A, B, C, and I have ending point. Okay, let's make it A1, A2, A3, and ending point is B1, B2, and B3. Okay, so the straight line, its parametric form can be just written as RT, which is A1, A2, A3, plus B1 minus A1, B2 minus A2, and B3 minus A3 time t, and if you let t equal to start from 0 to 1. So you can easily verify that R sub 0 is just A1, A2, A3, and R sub 1 is just equal to, when the t equal to 1, so it's just the sum of the two, right? It's just A1 plus B1 minus A1, of course, is B1. And the sum of these two will be just B2, and it will be 3. So because this is also a straight line, as I mentioned before, so it represents a straight line. So this represents the straight from A1, A2, A3 to B1, B2, B3. Okay?